Hello guys. Namaste. Perev Ndiepi San Bonani. Anyway, we have a Dell motherboard, and that these days I'm not showing you the entire laptop. I'm just showing you what the board. We have the motherboard here right in front of me. Anyway, I don't know what is going on here, but they told me that this board is not turning on at all. So we have to see. I have to open this machine and see what exactly is going on. Let's go ahead. Let's connect the DC bench power supply. So how do I connect a DC bench power supply? You know how I do it. I normally put my signature here, the ground, and on the current sensor here, I will put flaxi. Let me show you how I do it. You will have the first MOSFET, the second MOSFET. After the second MOSFET, what do you have? The current sensor. You will have the current sensor. Okay, so what's okay, let me just show you the current sensor. Do you want to see the current sensor, or you'll be fine? All right, let me focus. We need to focus. Okay, let's look for current sensor. Remember what I told you? You have the first MOSFET. After the first MOSFET, you have the second MOSFET. After a second MOSFET, you have a current sensor. So right here on the current sensor, that's exactly where I'm gonna inject the 19 volts, because I want to power on this machine using a DC bench power supply. So this is how you inject the 19 volts. Yebo. And then check my probe. All right. And then after this is my probe, my red wire. I'm injecting the 19 volts. Okay. Okay, I made a mistake. What about my ground? Supposed to inject the ground. The ground serves my signature. All the boards that have been touched by me, they all have what? The signature, my signature. They all have my signature. These are two wires, the positive, which goes here on the positive, and the ground, it goes where? Straight to ground. It goes straight to ground. Okay. Before I burn myself, I need to be very careful here. Okay. I was using a nice flaxi there. So that flaxi, you can find it on my online store, jbvcomponents.co.za, and you can WhatsApp me on that number there, +27 061 457 3563. That's my WhatsApp number and my phone call. You can even call me direct. It's all up to you. But anyway, let's go ahead. And what else did I use? Oh, I used a nice wire. I'm using this nice soldering wire, which is 25 rand. Okay, if you're around South Africa, let me know. I'm gonna give you all the best and the good tools. Okay, let's inject the power. 19 volts. Okay. Something is taking a little bit of power. Let's press the power button. Pressing the power button. Nothing is happening. Power button, nothing is happening. The power button, nothing is happening. The power button, nothing is happening. Okay, so there's no way. Oh, okay, wait. Sometimes with some other laptops, if you jump the power and then you inject it after the current center, they won't turn on. So the best option is to inject the power before the current center. Let's switch off the different power supply. Let's flip the board. Oh wait, let me remove this wire. Maybe that's why it's not turning on. Okay, the power has been injected on the 19 volts. You can see my red wire. You can see my red wire there. I want to spoil you. Let me show you under the microscope what exactly I did. Okay, there we go. So it's been I injected the power there. Why there? Because we have three red wires which are all positive, and the yellow is for data for sending the charger, and the other one, the black one, is ground, obvious. Okay, so yep, everything seems to be fine. Let's go ahead. Let's inject the 19 volts, and then let's see what is going on. Let's see what is going on. Okay, the board is doing the same thing. Now turning on. Turn off the DC bench power supply. Let's flip the power. Now let's check for the 19 volts. Turn your meter into voltage mode. Okay, let's turn it on. It's on the voltage mode. Let's check the current sensor. We do have 20.8, 20 volts. Now we need to check 3.3 and 5 volts. We have 3.3. Nope. What about 5 volts? Nope. Oh, wait. Let me check again. 20 volts. Yes. What about 3.3? Nope. 5 volts. 0.047. We don't have 3.3 and we don't have 5 volts. Okay, let's find a schematic for this board. You use the board number. Okay, on my PC, go online, you go on the internet, but I'm gonna go on my PC because I have the schematic. I believe I have the schematic for this specific board. This board number is what? Let me search for that. Okay, there we go. 13269-1. There we go. This is the schematic. Okay, 3.3 and the 5 volts is easy to find. I'm going to show you. You don't have to search for it. You can just see it. You can see it because there will be a chip in the center, and on the right and left there will be 3.3 and 5 volts depending on the board. Okay, it's gonna be something like this. There we go. We have the 3.3 and the 5 volts. I believe this chip Pwb Fx3mc is responsible for generating 3.3 and the 5 volts. 3.3 and the 5 volts. 3.3 and the 5 volts. Okay, so what do we check? Let's check one thing. You know, every chip on the board, it should have the enable. I'm not all, but most, they should have the enable. So this chip on pin number 1, oh, no. On pin number 20, it says enable. Pin number 12, it says V in, voltage in. We need to check if this chip does receive voltage, of which is 19 volts, and I believe this chip does receive 12 volts. After checking that, we'll check if the chip does receive those two enable, the enable for 5 volts and the enable for 3.3 volts. Before we even blame the chip and check the chip. And again, I'm a little bit concerned because here we should have 5 volts. The moment we connect the charger, right? We should have the 5 volts. Or unless if it's not 5 volts always, but I believe it's 5 volts always. But let's check. Just watch me. Let's start with pin number 12. Okay, there we go. You can see there's a dot there on top. Okay, wait. I'm showing you a wrong chip. Correct chip is this one. There's a dot here, pin number 1. Pin number 1, 2, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pin number 12 should be enabled, so we can check the enable right here. All right, let's check the enable. Turn on the machine. It's on. Put your meter into voltage mode, and then you go ahead and you check pin number 12. Do we have the enable? Let's go ahead. Yes. No. Pin number 12, we have 20 volts. How come the enable on pin number 12? How can it be 20 volts? We have pin number 20. We have 20 volts there on pin number 12. Okay, yeah, I made a mistake. Pin number 12 it should be 20 volts. It's the power to the chip. Now let's check pin number 20. Pin number 20. Pin number 20. 20 is the last pin. So the last pin should be like 2 volts, 3 volts. It should be an enable. And pin number 6 is enable. Pin number 6 and pin number 20 are enabling what? 3.3 and 5 volts. So let's check pin number 20 and pin number 6. Let's go ahead. Keep in mind the machine is on. I said pin number 20 and pin number 6. The last pin here. Okay, the chip does receive enabled. I have 3.3. What about pin number 6? Okay, I do have pin numbers. I do have 3.3 on both sides. I'm not sure if you can see. Let me show you again. Just check the multimeter there. 3.3. Now let's check pin number 20, the last pin. 3.3. The chip does receive. Okay, guys, let's talk about this thing. Let's talk about this. Let's talk about this. The chip does receive 3.3 on both sides, meaning the chip has been enabled, but it's not turning on. Let's check if the chip does generate LDO. You know LDO, or you never heard of LDO. Let's check if the chip does receive, because the chip does receive power 20 volts. It does get enabled, both enables for 3.3 and 5 volts, but still the port is not turning on. There's no power, there's no 3.3, there's no 5 volts. Now let's check the LDOs. Okay, where's the LDO? LDO. Oh, there we read pin number 3 and pin number 13. Pin number 3 should be 3.3, and pin number 13 here, VREG voltage regulator. So let's go ahead and check if the chip does get those. Okay. Let me calm down. Let's go ahead. Pin number 3 and pin number 13. Pin number 3 and pin number 13. Let's go ahead. Let's check those pins. Pin number 3 should be 3.3 volts. It's VREG 3. Yep, 3.3 is there. And pin number 13. Pin number 13 should be 5 volts. And 5 volts is there. Then what is going on here? Like, what is going on this board, guys? What is going on here? What is going on? Now I don't understand what is going on. We have 3.3, we have 5 volts. What exactly is going on here, guys? But the board is missing the 3.3 and 5 volts. I believe then those 3.3 and that 5 volts, they come maybe they come after the power button. So let's see. But there's something taking 0.06, 0.06. Nothing. I don't know why the 3.3 and 5 volts are not being generated, because this chip has all the working condition fine. It does have 12 volts, 20 volts in pin number 12 V in. It does get the enable 1 and enable 2, and it does generate VREG 3 and VREG 5. Guys, I don't know what is going on here. Oh, wait. Let's check the power button. Possibly the power button might be faulty. Let's check the 3.3 and 5 volts on the power button. 3.3 is there on the power button. Okay, switch your meter into continuity mode. But the machine is not turning on. Hi, this is strange. Reset the CMOS. Count to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 28, 29, 30. Right. Turn the machine on. Still. Okay, let me experiment. Let's 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 experiment. Oh wait, let's check for short. Let's do a code scanning. Continuity mode. Check 3.3. Okay, let's just check. I'm gonna pick up any chips randomly. There we go. We have a shot. Four ohms here. I'm confused. Why? 4 ohms again. Guys, there's a short here. I'm confused. Let's check down the chip. Okay, the chip has been removed. So I believe the chip is for sound. It's a Realtek chip. So I'm not sure. We still have a short after removing the chip. Okay, what is going on here? Let's check the 5 volts. We have a short on P. Okay, we have a short here. This is PL4502. PL4502. Let's see. Oh, this is not good. PL4502. It's for 3.3. This is bad. You know why I'm saying this is bad? It's because it's even possible that that short is coming straight from where? From the chip, from the CPU, from the PCH. I don't like when the 3.3 volt it's been shorted. I hate it. I hate it, guys. Ha, damn it. PL4502. Shorted. There's a short there. Let me confirm again. PL4502. Yep, there's a short. Yep, there's a short on PL4502. I don't like this, guys. Please, 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 please. I don't like this game. No wonder why we were missing 3.3 always and 5 volts always. This means this chip, the chip is fine, but there's a short somewhere. Let's prove that. Let's prove that. You know how we're gonna prove that? I know you already know the answer. I know for sure. The only way to prove that is to inject what? Is to inject power, the 3.3, to inject the 3.3 where there is a short. We're gonna inject what? The 3.3. Where there's a short, we're gonna inject what? The 3.3. Whew, I hate this. With all my heart. So the short is here. Okay, before you do a mistake, any mistake, you remove this because the DC bench power supply it's set to 20 volts. So you need to put it to 3.3, even 2 volts. Even 2 volts, guys, 2 volts will be fine. Yep, it's set to 3.3 now. I'm selling this nice set of screwdrivers, and if you need any, go to my website. You can buy there. Don't delay, buy there. Okay, I'm using this, so watch this, watch this. This way I put my 100% alcohol. You have to pack this, pack this, pack this. Okay, there we go. There's alcohol now. Let's clean this, the thing is so dry. Just pack it like this. I'm cleaning the PCH and the CPU just to show you that the issue here has got to do with a faulty CPU and a faulty PCH. Faulty CPU and the faulty PC what? PCH. I don't know why it's not PC, it's PCD. Okay, we have PCB and this is PCH. What about PCA, 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 PCA? Let's use all the letters from PC, PCH, PCB, because we have PCB, we need PCD, PCF. We need all the letters. Okay. The reason why I'm cleaning the PCH is because I want to show you that the short, I bet with this. And if you need this, the alcoholic dispensers, this nice one, you need to go to my website. I'm selling them. A bunch of them, guys. If you need any, I have a bunch of them on my website. Go there and buy, they're cheap. Let's inject the power. And then we need to search on what is getting hot. Taking 1.5 amps. Now it's checking 2. Yo, this is the short is coming. The short is coming from the PCH, and it's getting hot. I'm telling you. This is the CPU, and this is the PCH. So observe this. Observe this. Putting alcohol. You can even see those small particles there. Watch when I turn on the DC bench power supply. Now I'm turning on the DC bench power supply. Observe. Hope you saw. And the short and the shorted section is not this one, but it's this one. Observe, 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 observe. Oh, there is a track on the PCH. The PCH is tracked, guys. Can you see a track there? There's a line there. It's tracked. It's broken. Not even one line, but 3 lines. See? PCH is shorted. The CPU is fine. See, the CPU is fine. Nothing wrong with the CPU. But the problem is here. This is our problem, guys. So this thing of having shorted PCH is starting to be serious now. To be very, very, very serious. See there? Okay, this is the CPU, right? The onboard CPU. I don't know what generation is this, but this is just a sample to show you. So that tiny thing there, the tiny dial on top there is called the PCH. The other section, the bigger section, the longer section, that's the CPU. But this tiny thing there is the PCH. The platform control hub, and it's 3.3 volts. It works with 3.3 volts. Ish, guys, this is so sad, eh? This is so sad, so sad, so sad, so sad. Let me show you one more time. I'm enjoying talk chatting this PCH. Anyway, guys, there's nothing I can do here except to remove the the entire CPU, of which I won't do. I don't have the proper machines, even though I'll be doing it soon, but I don't think I'll be doing CPUs. CPUs are something else. Okay, I hate them. Bye bye.